Hi everybody, I'm Addison Snell with Intersect360 Research. We are, for those of you who don't know me, analysts who cover the high-performance computing space. Increasingly, that keeps covering more and more commercial areas. You might think of it as like high-performance enterprise. It goes beyond academic and government supercomputing sites through high-performance technical computing, high-performance business computing kinds of applications, including overlap into cloud, overlap into big data, overlap into what we're now calling hyperscale for the ultra-scale kinds of environments that you would get at a big internet or search company like Amazon or Google or Yahoo. You're seeing a lot of influence from things like Open Compute Project, OpenStack, starting to have influence into the HPC space. That's another kind of very high performance or highly scalable type of environment, but it's distinctive from things that we don't cover, like just regular old web servers or email servers or your ERP system, your payroll database, that kind of enterprise computing, not part of what we cover. And we've been delighted to continue to participate in these HPC Advisory Council meetings. We find these to be really powerful user group meetings that really stay on top of what a lot of the technology trends are as we look forward this year, next year, going forward. And it's an exciting time in the HPC space right now. My partner, Chris Willard, our Chief Research Officer, likes to call it an ancient curse. May you do business in dynamic markets. And from an HPC perspective, that's what we have right now, is a very dynamic market. And it's something that we've written about in a few different ways as part of our new partnership with top500.org. You'll find our podcasts and some of our blogs and articles over there. We're delighted to have that partnership. In addition to our other media partners that have access to our research. But what we're really looking at is, historically, if you think about high-performance computing, you can mark it in different architectural eras where you'll hearken all the way back to the vector era, and people talk about the vector like craze and the like. And then that gave way to a RISC-based SMP era. You'd have the SGIs and the Suns and HP and IBM with their RISC-based shared memory high-performance computers as part of a scalar revolution that took over from vector. Then around the mid to late 90s, things started to transition again, and we went over to clusters. It was really the Beowulf revolution that took us from SMPs into clusters. And where we are today is really just now a couple years into what's become a new era in high-performance computing, and that's marked by a movement towards more cores, the multi-core, many-core era, which includes heterogeneity. And the reason this is worthwhile in terms of thinking of as a different era is because there are things that it has in common with the previous shifts. First of all, they've all been driven toward what at every different era gets marked by people calling a democratization of high-performance computing, where you get a lot more flops, it gets a lot cheaper, and people say it'll expand the reach of high-performance computing, and that's always been true. You can get better penetration of RISC systems over vectors, better penetration with clusters over RISC systems. All of these things have done to expand the market, increase the peak flops, move us up in top 500, and multi-core and accelerators are doing the same thing. Another thing they all have in common is when you change the architecture like that, you have to change your programming model. The programming models all changed when we went from vector to SMP, and again from SMP to clusters, where MPI became the new standard. Going back to the early 90s, you didn't have your codes written in MPI, and then it took a few years of people going through this MPI standardization in clusters, but eventually it all went over. Now we're really facing again this new transition where people are revisiting their codes. DK gave a great talk on this morning, and it's been a major theme of all the conferences I go to in terms of how are we going to re-optimize our applications for a new architecture. And you'll hear people talk about, of course, the Intel tools and CUDA and MPI plus X. MPI plus X is kind of my favorite term that goes around the industry right now because it makes you feel like you have a plan where all MPI plus X really means is we're going to start with what we have today, which is MPI. We'll add something that we haven't defined yet, and then everything will be okay. So MPI plus X is kind of our placeholder for we're going to invent something based on where we are now. And there are a lot of different ideas for where that's going, but I think that we're not really sure as an industry yet exactly where that's going. And that brings me to the really crucial, important difference with this era, which is if you go back to the Beowulf ideal of when clusters first became popular, a big reason people were touting MPI and clusters was the notion of portability and standards. That one thing clusters gave you was I could put my code into MPI, and then whatever cluster I adopted, I could move my application around. It got you out of a vendor lock-in, where now an HP cluster would be the same as a Dell cluster or same as a cluster that I just racked together myself by collecting discarded servers from around campus, put it together, run MPI on it, and it would be portable. That notion of portability and standards is now swinging hard the other way, because as we go to what are now really proprietary architectures, whether you stay on a standard x86 and you cope with just what is multi-core bringing to me, or do I go to an accelerated x86 or a GPU computing, some kind of APU from AMD, or go to FPGAs or on power or floating point DSPs, or there's a number of different architectures that are all part of the discussion, but you don't have any kind of sense of portability on if I'm really going to optimize on Xeon Phi, that I could then pick that up and move it over to an NVIDIA GPU later. And that right there is the major stress point that we see in the industry right now, where we're seeing a lot of adoption of all of these different components of GPUs, of Xeon Phi, of multi-core, of all of the different processor technologies that are out there. But there hasn't been a wide-scale, wholesale adoption of one versus the other. And when we talk to end users, what we find is a lot of stress around not knowing what the architecture I'm going to want to be on in 5 years is. That's what we're grappling with right now. So it's as hard as any of these era movements have ever been, but it's actually harder because of that lack of portability or the notion of standards. This is prominent in industry right now. As I said, HPC continues to grow in industry, whether you're talking about a hyperscale kind of thing or high-performance business computing like in finance, high-performance technical computing like in manufacturing and oil. Now, this was a US-based study, which I'll say with only a little bit of apology. It was funded by the United States Council on Competitiveness, so they were interested in US industry predominantly, and we surveyed US companies for this study. My personal analyst opinion is that the findings in this study would extrapolate very well to corporate environments in any country. I don't think there's anything specific about a US company that makes it a lot different from a German company or a Swiss company or a Malaysian company with regards to how it deals with supercomputing. But we did this report with the United States Council on Competitiveness to look at how companies were evaluating supercomputing technologies, HPC technologies, how they were used today, how they wanted to use them in the future, what's the the desire for greater levels of scalability, the drivers and barriers for getting there, and the path forward. This is a free download. This is one of the times I get to say this. Normally I get to the end of the presentation, I say, and anyone who wants more information can call us and buy it. This one, you can go to www.compete.org and download this full report because it was funded by the council. It is good reading. It looks daunting at 75 pages. But don't panic. The back third of it is all appendices, and you can either read them or not read them. And then there's a lot of friendly tables and charts and quotes and things like that through the whole thing. It's actually a fairly entertaining read. I'll just highlight a few things from it. This is asking people on a scale of 1 to 5 how much more performance could they use over the next 5 years. And you're seeing the blue bar at the end is a disagree, and then it goes through the greens are neutral, and then out on this end are the agree in purple, strongly agree in this blue here. And there are agree, disagree questions from we don't see any kind of need in increasing application speed, size, fidelity, complexity. You can see that 2/3 of respondents disagreed with that, and only 10% agreed with the idea that they don't need anything more. And then it asks about, well, we could use double the performance, 5x the performance, 10x, 100x, 1,000x the performance over the next 5 years. And what's really impressive is where you look and see that 2/3 of respondents are saying that they could use 10x performance increase over the next 5 years. 10x in 5 years is pretty good, and there you're saying that 2/3 of commercial respondents would be happy to get a 10x performance bump in 5 years. They could consume it. And if you go up to 1,000x, it still stays at over 1/3 of commercial respondents are saying they could use a 1,000x performance increase within 5 years. Now, how they're going to afford it or implement it, those are all different parts of the survey. But the point is that there's a need for that kind of consumption. People want it. So what keeps people from getting there? This is the barriers to scalability. It's another 5-point scale asking how much of a limitation is this. From the 1s, it's not a limitation, up to the 5s, it's a severe limitation. There are different ways to look at these. You can look at the distributions of 4s and 5s, or of 3s, 4s, and 5s, or take the average score. But almost regardless of how you look at it, scalability of software really winds up being the #1 barrier that people look at for reaching a 10x improvement in scalability. Now, we also take this and we asked about that 1,000x level, and scalability of software stays as #1 or #2 depending on how you're counting. Is it the average, or is it the 3s and 4s, or what you're looking at? But it's either #1 or #2, where the other one is the cost of the hardware, if you're looking at trying to get to 1,000x. So cost of, how do I afford 1,000x more scalability? That's right there. But scalability of software beyond the cost of the hardware itself winds up being this #1 concern running forward. Now, there's a lot of things on here. It's not like you can just say, I'm going to take expertise and throw it out the window. There are all kinds of barriers. We need to address all of these on the road to exascale. The council at first wanted us this to be an exascale study, by the way. The initial drafts of the survey all said exascale everywhere. But what we found in the qualitative research, when we did about a dozen phone conversations with companies to start out with, was that anyone we talked to on the phone, first of all, their immediate line of sight tended to be this year's and next year's upgrades, which didn't get you to 10x scalability, let alone the next step beyond that. And really, when you got them to imagine into the future what could be possible, they had a hard time going beyond the idea of 1,000 times more powerful, which meant unless you're talking to a company that was already at petascale, and there are very few of those, that exascale was beyond the horizon of what they wanted to plan for. So we kind of toned down the exascale talk and went to this idea of 10x, 100x, 1000x, and that's how we scaled that throughout the survey. But all of this is going to be part of the exascale conversation as we go forward. Now, here's a big reason why this exascale, or why the software scalability is such a big problem. This is a funny looking chart here, but I'm going to explain it to you, I promise. It's actually pretty nifty. The basic question here is looking at what is the mix of application software at the site between software that's commercial licensed purchase software, like I went to ANSYS and I bought Fluent, right? So it's a commercial ISV package, versus software that's open source that I downloaded, versus software that is written in-house. So you can take those three and say, well, I'm 40% this and 40% this and 20% that, and put them onto a scale. When you take three numbers like that and add up to 100%, like if you had two numbers that add up to 100%, you could put them on a line segment, right? and divide it up that way. When you have three numbers that add up to 100%, you can map them onto an equilateral triangle, and it works. And the way you read it is the percent of commercial ISV software is going vertically through the blue line. So if I had no commercial ISV software, I'd be at the base of the triangle here, it'd be 0. And then you go vertically through 20, 40, 60, 80, and this apex at the top here would be 100% commercial ISV software. If you want the percent of open source software, tip your head 60 degrees to the right and read this as 0% and go down to the right through the green line. So this is 20%, 40, 60, 80, 100% at this vertex. Or 60 degrees the other way, this is 0% in-house on the right-hand side, and it goes through the red lines to this vertex is 100% open source. Everyone with me on that? It's actually not that hard once you get to it. And what you find, though, is that all of so this line, this dot here, this green one, which is biosciences, you could read as about 45% commercial ISV, is about 35% open source, and is about 20% in-house. So 45 plus 35 plus 20, that adds to 100%. So it works. But what we found is that these numbers are really starting to cluster in the middle. And this is an area where traditionally I think people would associate commercial buyers with commercial software. They have a much higher likelihood of buying licensed software. And 5 years ago, that was true. 5 years ago, you'd see a much higher percentage of commercial ISV, not just in the engineering-driven areas like manufacturing, although it would be most prominent there, but across all of them. And they've all been migrating downwards over time. That's not just from this study, but from our other research. The reason for that is this shift in architectures, where you go to multi-core and many-core architectures. That has stressed the licensing models for the ISV community, where the scalability for a software provider becomes another challenge, where they have to try to re-optimize these applications for their own customers. But also, the end customers don't want them to get any more expensive either. And if you're trying to license per core, for example, then the end user says, well, that's too expensive now. I'm going to go get it from open source or write something in-house. In manufacturing in particular, we saw a big movement toward in-house software for a couple of years, and then that gave way to open source. Open foam is the fastest growing application we've been tracking, taking share away from Fluent in the market. Now, share is kind of a funny concept when you talk about software, because it's not revenue share. People aren't paying for open foam, and they are paying for Fluent. But if you're talking about by usage, that kind of share, then open foam is really very fast growing. Now, it's not that there aren't some differences here between the industries, most notably in the percentage of in-house. They stretch more in this direction than they do in the other directions. So you see biosciences with the least in-house, energy and finance with the most in-house. That's also consistent with our other surveys. But really the bigger learning here is how they're all clustering toward the center, and this black dot that represents the averages of all respondents is in this center triangle that's not more than 40% to anything. Now take that back to what I was just saying about scalability of software. That's where this challenge comes from. I'm trying to get my software to scale into the future for this demand that I know I have for greater scalability, but I don't know what architecture I'm going to want, and I don't know how I'm balancing in-house versus ISV versus open source. So I've got all these different sources of software. I've got all these different architectures I'm evaluating, and I'd like it if my software budget didn't go through the roof. That's just further illustrating the challenge of where we are in the industry right now. Now that said, the demand for HPC isn't going anywhere. This is a new chart I've just added in. This is fresh from our most recent budget map survey, not even published yet. But what we're looking at here is budget expectations from survey respondents, everything from down more than 20% to up more than 20%. The blue line is, the blue bar is what people reported was their change from last year. So prior year to current year, what kind of change did I have in my budget? And then the red line is what kind of changes I expect over the next 2 years. So this is, we use this question to try to help us as a leading indicator to assist us in our forecasting where we think things are going to go, and we break this down by sector and by vertical market and geography and all kinds of other things. But at the top level, what you can see here is general optimism that's getting even better over the next 2 years than where it was the prior year. If we roll this back a couple of years into 2011, you could see where we really did take a very recessionary dip, and it took some time to roll this back out forward. It's been the commercial sector that's really driven the growth the last 2 years going into this year, in particular because government spending has remained repressed worldwide, really. There's not a geographic area that's been great on government spending right now. The U.S. has continued to grapple with their government sequester and funding there. We've had the ongoing Eurozone crisis here. Asia Pacific is hit and miss depending on what country you're talking about. So there really hasn't been a huge government surge yet, although we're starting to see some of that thawing with reason for optimism going forward. Now that top level budget gets broken down into different categories. This is the big feature of the budget map survey, is that we ask people, and if you respond to our surveys, by the way, thank you very much, and anyone who responds to our surveys can get access to these full reports. So there's a bit of an incentive there to do that. We just did a call with our HPC 500 user group where we went through all of this data in more detail. But at the top level, survey respondents break out their spending into major categories: hardware, software, staffing, facilities, services, cloud. Then every one of these categories gets broken down farther. Hardware might be servers or storage or interconnects. Software, there's all the different software categories from ISVs to system software, storage software, middleware tools, etc. So we can break down all of these. The interesting thing is that staffing typically gets underappreciated at these conferences in terms of the role it takes in the budget. I think mostly because not a lot of end users say it's a big goal for them to reduce their staffing costs, which would be code for I'd like to lay a whole bunch of people off, right? In general, people would like their staffing percentage to be nice and healthy. I don't want to have to fire people, and I like it when I get to hire people. Hardware has fluctuated a little bit. We saw it decline every year from 2007 to 2011 as a percent of budget. But then since then, 2012, 13, it's popped back up again. Part of that was coming back out of that recession, but I think part of it is just a renormalization to how much of the overall budget hardware takes up. Facilities has been pretty stable at 10%, although it's interesting to note that Another option in this survey is that any respondent can flag any category or any item within a category as not in budget, which means somebody pays for it, but it's not me. And facilities is where that comes up the most often. About half of respondents say that facilities costs are not tagged out of the HPC budget. The very interesting thing about it is that that percentage is going up, which is to say the number of people who do pay for facilities out of their HPC budget is going down. I would have expected it to be going the other way with the increased focus on power consumption, but what we're really finding is the increased focus on power consumption is lifting it up to the general IT level, where the overall IT manager now has oversight over facility spending, including power and cooling and rack space, and then you get your designation, your allotment from the overall IT boss. Okay, vendor news from SC14. We're a few months out from this now, and I think people have largely digested it, so I'm not going to spend a whole lot of time on all these bullets. The biggest news from our perspective was the Coral wins from the United States Department of Energy, most notably that they were big wins for open power and for GPU computing. Now, there's supposed to be a third computer there that still hasn't been publicly announced. This was 2 out of the 3. Coral stands for the coalition of Oak Ridge, Argonne, and Livermore, and they did the OR part and the L part, but not the A part. We haven't seen yet what the Argonne computer is. Presumably, it will be something that is Intel architecture, because they already announced up front that it wouldn't be all 3 the same architecture. So if open power and GPU won 2 out of the 3, I think it's a pretty good guess that Intel will win the third, but there's nothing stated publicly on that yet. This was important for not just NVIDIA with GPU, and they do a great job on their PR, but for the Open Power Consortium, which Mellanox is also a part of. You know, IBM, this was their first big win since splitting off the x86 business to Lenovo. I think IBM needed to show very strongly that they're still going to be in the supercomputing space, so this was validating for them. It validates the open power concept with a big $100 million supercomputing win, so it's a lot of momentum for open power going forward. It really sets up what's become a game of shifting allegiances in the high-performance computing space. And this is this undercurrent dynamic that's going on now. We're now really, there's a line in the sand that has Intel on one side of the sand and screw you Intel is on the other side of the sand. And IBM with open power has kind of designated itself captain of the screw Intel team. And they'd like to recruit members to the screw Intel team as much as they can. And that's a lot of what's behind this Open Power Consortium is they want there to be a non-Intel alternative. So IBM really has gone all in as being strictly a competitor to Intel. They don't partner anywhere anymore. They've swept that clean, and they're going to compete with Intel on all fronts. Where that really becomes interesting is if you start thinking through other partnerships in this space. There are going to be clearly vendors that stay Intel aligned. Cray is going to stay Intel aligned. Lenovo will presumably stay Intel aligned. Dell will probably remain Intel aligned. HP right now has a foot in both camps. And you know, how long can they continue to do that? It becomes interesting. But even for a company like Dell, all right, today they put out this very dense GPU form factor. It's a 1U server with 4 NVIDIA GPUs and a Mellanox interconnect and an Intel processor. Can they do something similar to that 3 years from now or 5 years from now, where you have an Intel processor and a Mellanox interconnect and an NVIDIA GPU? That becomes less clear. You know, do you have to be all Intel or no Intel down the road? accelerator roadmaps all went forward. I don't want to miss this one, though, the Bull one. Bull revealed a roadmap that I think didn't get enough attention, where they more or less said they can deliver an exascale system by 2020 if they had funding for it, which, whether there's any kind of announcement from the European Union or the EC or not, I think brings the European Union into the exascale discussion. I think it drops the challenge to say, would CEA, for example, want an exascale system in 2020 if a vendor like Bull says they can build it? I think it brings Europe right into the exascale leadership discussion again. Lenovo, SGI, Dell all had these announcements. Huawei was interesting to me because they're starting to show up again with a story that's very similar to how SGI talks about things with their big in-memory solutions. Mellanox with 100 gigabits per second was very notable, and we started seeing more ARM chips, so kind of completing all this diversity around here. I already talked about Intel versus the world. Flops giving way to data centricity. This is another kind of interesting idea here where there's a lot more talk about other ways to evaluate a system other than flops. I think flops are good. I think flops are fine. I'm a fan of the top 500 list. I think the more complicated things get, the more you need lists like top 500 to help do a simplified ranking of things. I don't think it should be the only way we measure anything, but I think you need more of things like top 500, not less of things like top 500. I think the HPCG benchmark is a nice step forward, and I think what we'll see is an evolution of more ways to measure things. Now, with data centricity, this is more around the IBM messaging of data-centric computing and talking about things like moving the processors to the data rather than the other way around. That always sounds good when you say it, but leaves me a bit of a question mark when you say that you're going to move processing to the data, because all right, I'm not an engineer on this. I've seen briefings, but I don't think anyone has actually developed any kind of ambulatory processor that gets up and walks around to where the data is, right? You have to get straight that the data is the only thing moving here, okay? The processor does not move. It's not going to move. So what you can say is you're going to try to locate the processor closer to the data that it might want. That would be fine. But you're not really moving the processor anywhere once things are in flight. That said, different architectures that emphasize data movement over flops I think are going to be interesting. Data Vortex is a fun little company we've been tracking behind the curtain for several years that has such an architecture. A3 Cube is another, just to name a few companies that are out there. So the year ahead, we are going to see a reshuffling in market share. IBM historically has been the #1 server vendor in HPC by revenue. They obviously will not be anymore. Lenovo immediately gets established, presumably as the #3 vendor by revenue behind Dell and HP. Whether or not Dell or HP is #1 in 2014 is not a number we've officially come out with yet. Dell would be the incumbent with a very slight lead ahead of HP, and we've got to really run the numbers before I'm ready to say that Dell was #1 in 2014. But I'd say that would be the favorite. It's possible that HP will have moved past, and you'll hear from us probably in May as we finish going through all the numbers on that. The interesting thing to me would be whether or not Cray becomes the #4 vendor by revenue ahead of IBM. That's going to be close. If you'd asked me a year ago, I would have said, no way, IBM stays ahead of Cray. But IBM did not have a good year, and Cray did, and it's going to be close. Cray and IBM are going to be close in terms of who's #4. I already talked about the end of the Beowulf era and moving ahead to more specialized systems. That's a major trend in the industry that's going to be ongoing. I already talked about ARM and open power. I'm doing this in no particular order. 3D memory is coming into the mix. This is going to be interesting. Micron has been an emerging company here with hybrid memory cube, and Intel is integrating 3D memory into Knight's Landing. This Intel processor with Knight's Landing, making the Intel Xeon Phi a standalone chip, I should come back around and say that's going to be very interesting in the industry as well. I feel like I've been Intel bashing for the first part of this presentation. You take a lot of shots when you're a monopoly, but Knight's Landing is something that we're seeing a lot of interest in across the industry. I think NVIDIA had a first mover advantage with GPU computing and CUDA, but there's a lot of Intel architecture out there, and I think Knight's Landing is going to get a really significant look. We are projecting, this is a forecast of course, that more than half of new HPC systems this year will include some type of accelerator or coprocessor. The majority of those will still be NVIDIA GPUs, of course, but there will be a lot of things in the mix. Big data is still a major topic here with solutions evolving for it. There's a metaphor I've used for this, which is that if you remember back to the early days of ERP systems, which was another major enterprise trend that got going in the late 90s, it was given a boost by Y2K. A big reason for enterprise resource planning was you had to ready your enterprise systems for year 2000 compliance, but eventually that subsumed Y2K and just became a major enterprise initiative where everyone had to get onto ERP systems. But in the late 90s, those were very expensive, consulting services driven, large enterprise only kinds of initiatives that would take you 18 months to 2 years to go through. You'd spend $1 million or more dragging your company through an ERP transition. By the time you got into the early 2000s, a couple years later, you started seeing standardized solutions or processes for ERP. Services and consulting still played a role, but it might cost less than $1 million and take less than a year. You know, you could get something for hundreds of thousands of dollars and it'd take 9 months. As that matured, you know, go and Google ERP right now. You'll find the Wikipedia page and a list of the top ERP software. It's something that people just go out and buy. There are ERP packages with different kinds of modules. It's a very standard thing. The reason I dragged you through that is because I think big data is on the same kind of vector. Early days of big data were like that, where it was a major thing where there aren't standard solutions. There's a lot of consulting at play. There's what am I doing with Hadoop? What am I doing with analytics? What does it really mean for my company? We're now a few years into that, where just now you're starting to see more standardized, more commercialized solutions. And it can't be for big data in general, right? Because I don't even know what that is. But there are different kinds of analytics packages, complex event processing packages, Hadoop packages, depending on what you're trying to do, and that will continue to standardize over time. We are seeing a return of big memory appliances, where with the YARC systems from Cray or SGI or other vendors are putting together larger memory configurations for doing in-memory computing. It's kind of funny to see shared memory coming back around again, but for some of these big data kinds of applications, we do see that trend. I already talked about data-centric computing. I think it will amplify this from a workflow perspective. Important technologies for big data, parallel file systems. I've been on parallel file systems for years. I think parallel file systems will continue to be very important. I say continue to be. What I should say is I continue to think they will be important, but they're still not well adopted in commercial markets yet. The incidence of parallel file systems in commercial HPC arenas is surprisingly low. It's on the order of about 10%. It should really be much, much higher. IBM will continue to push this with their GPFS solutions, which are now rebranded again, but are a core part of IBM's strategy going forward. Most of everybody else is going to be on Lustre. Intel, of course, is pushing Lustre. It's another major area where IBM is competing with Intel going forward. Windows and mobile clients, it's a big reason that parallel file systems aren't well adopted in commercial areas is you've got to interface with Windows. There are so many Windows devices in these commercial markets. This is the big thing that held back Windows from becoming an HPC platform. If you go back to 10 or not quite 10 years ago, Microsoft was making a big push for compute clusters in HPC, and they actually built several that made it onto the top 500 list. What held that back ultimately wasn't their inability to build a scalable cluster. In my opinion, it was their inability to get data in and out of it. They had no scalable file system alternatives for a Windows cluster. What are you going to do to get data in and out of a Windows system? They're just CIFS. I mean, there wasn't a good solution for that. So you could get the compute, but there was nothing on the data side, and that's, I think, part of what's holding back parallel file systems in commercial markets. Programming environments we've already talked about a great deal, and that extends to the middleware space, job scheduling optimization. Have to mention Flash. It comes up everywhere, and that, of course, has been on the rise. I'll go ahead and say tape because Torben made a crack about tape. Tape is growing, not shrinking or heaven forbid, dying. The incidence of tape is actually rising. And the reason is because it still offers the most bytes per dollar, the most bytes per watt, and the most bytes per floor tile, and your media lasts about 3 times longer without degrading. So you go into these big data environments, you're still going to find a lot of tape. It isn't going anywhere. Not all of big data is Hadoop. Very little of big data is public cloud. Very little of HPC is public cloud. There's still some areas of overlap. There's still some areas of desire, but the data movement kills it in a lot of these areas. And big one, sorry, there's still no killer app. This is the number one question we always get asked as analysts by our clients. Well, no, it's the number 2 question. The number 1 question is, can you give me the email address of the person who I need to sell to? The answer is no, generally we cannot. The number 2 question is, what's the killer app that we need to dominate to go get 90% of this space? That's also more complicated. In HPC, lifting away from big data for a second, then they'll say, all right, well, what are the top 5 apps to give me 80% of the space? In HPC in general, the top 40 apps will give you not quite 50% of the space combined. Right? It is a very highly disaggregated market. Big data is worse. It is entirely disaggregated. And in fact, 50% of the big data market is in-house applications and algorithms, which by definition are one-offs. So there goes half the market right away to stuff that's individual to any particular area. Hadoop is about 20% of it, with things that are based on top of Hadoop. But Hadoop in itself is a programming model more than an application, right? It's a construct. It's not an application in of itself. But think about, for all the enthusiasm you've seen around Hadoop, how many vendors have come out and said, we can help you scale your in-house applications and algorithms with better tools and a better programming model and things like that? That is like 2.5 times the Hadoop opportunity, and nobody's on that square, right? That is a big untapped area that more vendors should be moving into. Growth in the big data market, it will continue to grow, but it's a question that bugs us as an analyst, because what does it actually mean when you say the big data market in terms of how many dollars are being spent there? Because no one has defined for me yet what is one big data and how much does it cost, right? You see analyst reports on big data spending, and big data is going to be $1 billion and growing at 11% to whatever. Like, what are you counting, right? Specifically, what are you counting? How many things are you counting when you say the big data market? Because you don't go out and buy a big data, all right? That's not a thing. And you can say big data kinds of applications, but it's not any one application. And even then, you're presumably talking about an awful lot of hardware. But what we have found in our big data studies is that most big data initiatives begin with hardware I already have, with data I already have, with people I already have. I might go get some more software, but a lot of that is downloaded open source Hadoop kind of stuff. There's certainly some new software that I'm getting more SaaS licenses or Oracle, but I already had some of it, and now I'm getting more. So what's the aggregate difference in IT spending, right? Because you can look at, well, big data is going like this, but presumably big data is a subset of all enterprise IT spending, right? Which is flat, pretty much. So if big data is going like this and all of IT enterprise is flat, then really what you're doing is reallocating, okay? And there is an awful lot of that, where if you go ask, well, what portion of your IT budget is going to big data this year, you get a nice big number. But it's not necessarily a bigger number overall than you had before. Now, we do see more growth in big data oriented IT budgets than in non-big data oriented IT budgets. Where there is growth, it's in big data. But don't get yourself so overly excited about somebody's big data forecast that you fool yourself into thinking there's a lot of new money out there that wasn't there before. Okay, most of what you're seeing is a reallocation. So that was that rant. This is maybe my most important slide because it gets to not only big data but HPC and where the big problem in the industry is right now. So I already said on the HPC side we're going over to a whole new era in architectures. On the big data side, you've created this whole new application area you didn't have. Where are these skill sets coming from? Is the biggest gap that we have in the industry right now. Because you see things where people will post a job requisition now and they say, we want to hire a data scientist with 20 years experience in blank, blank, blank. Okay, data scientist is a title you made up last week, right? No one has 20 years experience as a data scientist because that wasn't a thing. No one majored in it. All right, there are related skills, sure. But if you're going to go say, I'd like to hire an experienced data scientist, get around the idea of what does that mean? All right, what skills do you want them to have? And be comfortable with the idea that a lot of people are trying to hire data scientists right now. And a lot of what job seekers are doing is rewriting their resumes to include the phrase job scientist wherever they can. But you're trying to invent data scientists on the fly. That didn't exist before, all right? So that becomes a skills gap in the industry where all of a sudden you're trying to hire things that weren't already there. And that tips back, and warning on the bottom here, I am here to tell you as a professional analyst that a bad analyst can do a lot of really bad analysis with good data, right? So when you get your new analyst or data scientists, wherever they came from, that becomes the crux of how successful this can be. I think this is a much bigger variable on the success of your big data initiative than how good your storage system is. Sorry to the storage sponsors, but absolutely yes, you want the performance in your storage, your networks, your compute, but who's running it becomes a very big deal. There's a huge opportunity here for anyone who can claim to have these skills. And this bleeds back over into HPC and what I was saying about new architectures and new programming environments. Just consider a standard title like sysadmin. All right, we've had sysadmins around HPC for decades, but if you were a sysadmin in the vector era, that implied a very different set of skills than what a sysadmin needed to do on a RISC or SMP system. And again, a very different set of skills than what you needed to be a sysadmin for a cluster. And now that's changing again. If you look at what you need to do in terms of system efficiency, optimization, what you need to know about middleware, what you need to know about programming environments, all of these skills are changing again. You can have the same title, and you have to reinvent what it is you're doing. So there's a major skills gap at play right now in the industry, and programming skills, services are all going to be in short supply going forward. So demand for HPC is absolutely there. Market, yes, continuing to grow. But we're swinging back to an area of specialization. That's going to be a major trend. Software scalability is a bigger deal than hardware scalability right now. You can put up a lot of peak flops, but the question is going to be how do we make those usable? Skill sets are a bigger deal than facilities. I spend more money on personnel than I do on power consumption, and that's where there's going to be a major lack going forward. Also, I didn't mention, but regulation is going to play an increasing role here, not only for things like how HPC gets deployed in sensitive areas like healthcare, finance, but also in the emerging areas on big data. I had a couple slides I took out which showed my big rant on personal privacy as it pertains to big data and analytics. Europe actually is ahead of the world right now with the new regulations in place concerning protection of personally identifiable information. I think the US has some catch up to do there, if there's even the desire to do any kind of catch up. I think the US government right now likes the extent to which it can spy on its own citizens without a warrant. I think a lot of that is going to come to a head in the next couple of years, so regulation will play an increasing role. Okay, that's it. Do I have time for questions? Sure. Great, thank you.
Any questions?
Tor.
Just wondering, could you say something about OmniPath versus InfiniBand?
OmniPath versus InfiniBand. I'm certainly not going to do any kind of benchmarking results. I'll leave that to the different vendors. And Intel thus far has not put a lot of its selling strategy into switch differentiation. They acquired the InfiniBand business from QLogic, but didn't immediately start waving the flag about what a great InfiniBand vendor they are. I think the bigger question there comes into play in terms of how it's going to compete out in a couple of years when you get to the next generation of integrated I/O, because I think what we're all expecting, whether it's formally announced or not, is that Intel will integrate NIC and HBA functionality on chip. And if Intel then makes the claim that if you're using an Intel processor, the on-chip NIC and HBA works better with an Intel OmniPath interconnect than anything else, then that's where you get competitive pressure on a non-native InfiniBand like a Mellanox. Now, Mellanox, Open Power are all very interested in competing there and making an argument for why that's not a good idea. I thought the multi-host announcement from Mellanox, when did you announce that, a week and a half ago? Was
HPC Advisory Council.
the ConnectX multi-host announcement from a week and a half ago, roughly, to me was extremely significant, more so than the amount of play that it got, because it gives Mellanox the ability to make a compelling argument for why the NIC functionality is better off chip. Other than raw performance claims, being able to do a multi-host path is something that Intel isn't likely to duplicate in its more of an SoC strategy. So I'm not going to go so far as to even predict who's going to win one way or another, but I think it's pretty clear what the two strategies are, and that's what you'll get to choose between in the years coming up.
In the parallel file systems, for example, Lustre versus GPU
What trends do we see in Lustre versus GPFS? Well, GPFS, starting there, is going to continue to be seen as a proprietary solution for IBM systems. And I think that is the most limiting factor. I haven't seen yet a whole lot of non-IBM storage companies lining up to. They'll support GPFS, but not promote it as a leading solution. Lustre is viewed as being more open, and you see more storage companies that will promote it as their leading storage solution. The interesting thing here to me is that, though, from a market share standpoint, and I'm going to kind of lift this up to storage in general, the big enterprise storage providers that have had most of the share, even though they don't focus on HPC, have been EMC and NetApp and Hitachi Data Systems. They are all falling back pretty rapidly due to the lack of any kind of high performance strategy. And you're going to see IBM and Seagate and DDN all on the rise, taking share away from the enterprise guys. So I don't even worry about the fight between Seagate and DDN that much, because there's so much NetApp share to go around and so much EMC share to go around that I think they'll just keep gobbling it up from the big guys. So I see IBM, DDN, and Seagate as the gainers. Panasys should be a gainer, but we just haven't seen it in the surveys yet. I think the market dynamics are right for Panasys, but whether it's a problem strategically or in the field, we haven't seen that same thing coming up in our surveys yet. Maybe it is, and we're just not seeing it. Now I got to bring it back to Lustre, GPFS. Really, for the big enterprise guys, what I really would have loved would have been for one of them to pick up PNFS and run with it. PNFS is like this forgotten initiative from 5 years ago, and it ran out of champions who cared about it. And there's still such a market opportunity in these commercial areas that the enterprise guys say they care about, whether they call them HPC or not, because they don't. But if NetApp, for example, had declared itself king of PNFS and moved it into these commercial high-performance computing areas, that could have been a real success that I would have believed in. Just organizationally, though, they can't get around the fact that they think it competes with ONTAP, so they won't do it. And I don't mean to pick on NetApp. Well, maybe I do. But I pick on EMC just as easily, and they don't want it to compete with OneFS, with Isilon, or MPFS on their enterprise side. So I think PNFS was this great missed opportunity that could still make a big splash in the market. I mean, it's essentially done and sitting there, and no one's using it. It's like everyone gave up on it. It could come back. Lustre should take most of the market without that around, but IBM will probably get most of the revenue with GPFS and its licensing scheme. Go over here.
Sorry, yeah. I thought Panasys was the champion of PNFS.
Well, they were. So the comment was that Panasys had been the champion of PNFS. They were the first ones to really make a big deal out of it. They launched it at ISC in, I'm going to get the year right, in 2008 or so. They made a big push on PNFS. They went through some change in leadership and eventually pulled back on PNFS and touted PANFS, their own file system and environment, as their core differentiation. They haven't really championed PNFS in the last 3 years.
One point you made with Microsoft clusters and file systems. I believe there was
A Microsoft client for PNFS?
For Panasys.
Oh, for Panasys?
Was I imagining that? Was it
I don't remember whether there was a Windows-based client for PanFS. I wouldn't doubt it. It's certainly possible. Microsoft was one of the members of the PNFS consortium when they were pushing their Windows compute clusters. But when they changed their strategy and put everything back under Azure, their interest in PNFS also waned. I didn't intend to do this much on PNFS today.
You could help us from asking about Linux containers. What
How long do we have to wait for what application containers in Linux?
Yeah, it is in both sides, the application or server side.
You know, I don't even know that much about containers, I'm embarrassed to say. It is a word that I'm hearing more in different presentations from the vendor side. They seem to all have virtualization in common, but I've also not heard one consistent definition of the word container from presentation to presentation. I think virtualization in general, you will see more in high performance computing, even though that seems like a bit of a contradiction. Usually when people talk about enterprise virtualization and containers, you're dealing with jobs that easily get fit inside one node, inside one processing element. And what you're trying to do is get one resource to look like many resources. And HPC is usually the opposite of that. You're trying to get many resources to look like one resource. I actually owe that analogy to Tim Carroll, who used to be at Dell. It was the first I heard that analogy, but I think it's spot on. So the idea of a container now spanning multiple nodes is a newer idea that lifts virtualization up into a more performance-centric area, and it's getting a boost actually from hyperscale, because it's the hyperscale people who would do a lot of virtualization for things like web serving, where you want to break up these small jobs and have a lot of them fit onto one processing element or on one node. They're the ones who've been using these virtualized containers, and now they want to lift it up for more complicated jobs that'll run in analytics or image recognition or other kinds of things that hyperscale companies do that are HPC oriented, but still within their same virtualization framework. So at a high level, I think frameworks are becoming more important. Down at the detailed level of when will they be implemented in what version of Linux and when will they become common, I don't know. That was a pretty good answer for I don't know, I hope, but I really don't know.
Pretty much, yeah. The other question.
Yeah.
You made a nice cake chart about budget.
Yeah.
Did you also consider spending for consulting, so renting people?
Yes, so the question was, did the pie chart for budgets include consulting? Yes, it does. Consulting usually is under the services area and is broken out there. There are cases where you can have a dedicated consultant who feels like so much a part of your staff that people will flag them as staffing, but I would say the consultants for the most part are under that services line. And we can break that out farther too and show you where they are. We've got line items underneath there. So it is part of the model, is the short answer. Other questions? Okay, I'd love to say I'll be around and you can get me later and ask me questions on the boat and everything. I'm going to go to Stuttgart in like a couple hours. So I'm sorry that I'm not here for longer this trip. I really enjoy these meetings. And if you see me this afternoon, great. Otherwise, I'll catch you at a future one or at ISC. Thank you.